Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, let me know quickly in the chats if all of you can hear me, if I am perfectly audible, visible to every one of you. Let me know quickly in the chats, people. Quickly in the chats with some fire emojis. If all of you can hear me, if I'm perfectly audible, visible to everyone. And yes, this is your NEET 2026 replica paper when it comes to the subject chemistry. Yes? Perfect, guys. Perfect. So in this session, you are going to have a look on the mixture of easy, moderate, and tough questions. So we'll be discussing some 45 questions, okay? And expect the questions directly, indirectly from these sort of questions, which I'll be showing you in the today's session. Okay? Perfect. All right, people. And at the same time, day after tomorrow, I'm keeping one extra session. Day after tomorrow, I'm keeping one extra session exactly at 10 a.m. on Saturday. That will be one more question practice session. That will be complete chemistry in 180 MCQs. Okay, do join that particular session as well. Perfect. All right, so are you guys ready with your pen and paper? Should we start? So first of all, tell me, how is the feeling right now? Just 2 days are left. I just want to know that first. How do you feel? Amazing? Nervous? Great? Yeah? I just want to know that first. After that, we'll start the session. Duration of this session will be 1.5 hours. I just want to know from everyone. Nervous, never panicked, stressed, chill, death scare, confidence. Chill, guys, chill. Don't worry. Don't worry. Chill. Calm down. Okay, I'm not talking about the stress and all. Okay, leave it. We'll focus on the session. I don't want to scare you more. I do not want you to get scared more, people. Okay. Let's get going. Let's get started. So my dear students, I'm starting this particular your NEET 2026 chemistry replica paper with the first question that's on your screen. It's going to be the confidence booster for everyone. This question is going to be the confidence booster for everyone, my dear students. Look at the question carefully. See if you will be able to solve this question on your own. Quick. SF4 is isostructural with. SF4 is isostructural with. My dear students, how do you deal with such kind of the question? How do you deal with such kind of the question? Have a look exactly how you guys are going to deal with this kind of the question, right? Frequently asked question. First of all, if I talk about my SF4, my dear students, I need to know, first of all, what is the type of this molecule. And once I get to know the type of the molecule, then easily I will be able to solve the question. Now the point is, how do we How do we get to know the type of the molecule? Try to understand. My dear students, this sulfur is your central atom over here. If I ask you how many valence electrons it has, sulfur belongs to oxygen family, so 6 valence electrons. How many surrounding atoms do you see? 4. Remember, the number of surrounding atoms is equal to the number of sigma bonds, right? So my dear students, sulfur had 6 valence electrons and it has utilized 4 valence electrons to form 4 sigma bonds. So there'll be 2 electrons left as such on sulfur in the form of 1 lone pair. So there are 4 sigma bonds, 1 lone pair. So if I ask you what is the type of the molecule, the type of the molecule is A, where A is the central atom. This is going to be B4 and L1. This is the type of the molecule. This is the type of the molecule SF4. Now I have to check which of these options over here is of the similar type AB4L1. I have to select that option. I have to select that option, right? That particular option which will be of the same type, AB4L1. Now, if you look carefully, my dear students, if I talk about this IF4 positive, understand what I'm going to do. Iodine here is the central atom. How many valence electrons normally iodine has? 7. Since there's a positive charge, so subtract 1. So it becomes 6. How many surrounding atoms? 4. So therefore 4 sigma bonds. Out of 6 valence electrons, 4 have been utilized. 2 electrons will be left as such on iodine in the form of a lone pair. So 1 lone pair. So what do you think is the type of the molecule? The type of the molecule is again AB4L1, right? Do you see these 2 molecules are of the same type? Yes. So they are supposed to be isostructural. So this is the first question which is done and dusted. Yeah. Perfect. Amazing, guys. Amazing, amazing, amazing. This particular molecule I'll be showing you in some time. Just wait for it. I have kept one extra question for this particular molecule, XeO2F2. All right, people. Moving on to the next question. Look at this particular question carefully. What do you think about this one? What do you think about this one? Quickly. My dear students, if you look carefully, they have mentioned in a closed, insulated container. Insulate means Q value is equal to 0. Okay? In a closed insulated container. A liquid is stirred. A liquid, you have taken a liquid. You are stirring the liquid with a paddle. You are stirring the liquid with a paddle. My dear students, you are stirring the liquid with the paddle. So liquid is my system and I'm stirring the system. So what does that mean? That means work is done on the system. We are stirring the liquid. Work is done on the system. And whenever work is done on the system, W value is taken as positive in chemistry, right? Perfect. Now, if I use the first law of thermodynamics, first law says that delta U is equal to Q plus W. Since Q value is already 0, so I would say delta U is equal to W. And is W 0 or non-zero? W is non-zero. So which option do you see is the correct one among all? Which option do you see is the correct one among all? So I would say delta U is equal to W, non-zero, and Q value is equal to 0. So it has to be option A. That will be the correct answer of this particular question. Is it clear? Is it clear, people? Yes. Moving on to the next question. Which is on your screen. Read the question carefully. Give it a try, people. Read the question carefully. Give it a try. A gaseous mixture of propane and butane. A gaseous mixture of propane and butane of volume 3 liters on complete combustion produces 10 liters of carbon dioxide at STP. Calculate the volume of propane in the mixture. How do we deal with this kind of the question? Try to understand. For example, this is the container which you have taken. In this container, you have kept propane, that is C3H8, and with propane, you have got butane as well, C4H10. My dear students, as per the question, the volume of this entire mixture is how much? Volume of this entire mixture is 3 liters. Perfect. Let's assume that out of 3 liter mixture, there are some X liters of propane. That means this 3 minus X. This is going to be the volume of butane in the mixture. This is the volume of propane in the mixture. This is the volume of butane in the mixture. Now, my dear students, as far as the question is concerned, the mixture is undergoing combustion. So that means you are adding O2 into this container. And when you are adding O2 into this container, what is happening? When you are adding O2 in the container, some reactions are happening. due to which carbon dioxide gas is produced. And what volume of carbon dioxide is produced? If I ask you, what volume of carbon dioxide is produced? I'll say 10 liter carbon dioxide is produced as per the question. So when you introduce O2 in this container, some reactions are happening in the container due to which carbon dioxide gas gets produced. And what volume of carbon dioxide gets produced? 10 liters of carbon dioxide gets produced. Now, my dear students, if you think logically, you are introducing oxygen into this container. So can I say this oxygen would be basically reacting with this one as well as this one? Now, when oxygen reacts with your propane, it leads to the formation of carbon dioxide and water. Similarly, when the same oxygen reacts with your butane, it leads again to the formation of carbon dioxide and water. These are the two reactions which would be happening inside this container. These would be the two reactions which would be happening inside the container. Now, my dear students, are the reactions balanced? No. Let's balance the reaction. This is 3, this is 3, this is 8, this is 4, and this becomes 5. Similarly, when you balance this reaction, this is 4, this becomes 4, this is 10, this becomes 5, and this becomes 13 by 2 times. So I'll balance the two reactions. After balancing the two reactions, look at the reactions carefully. Stoichiometric coefficient here is 1, here it is 3. So stoichiometry is telling me that when 1 liter propane undergoes combustion, 3 liters of carbon dioxide are produced. When 1 liter propane undergoes combustion, 3 liters of carbon dioxide are produced. But in the container, did we have 1 liter of propane? No. We had X liters of propane. So when X liter propane undergoes combustion, I would say 3X liters of carbon dioxide gas will be getting produced. So this is the volume of carbon dioxide gas which is getting produced from reaction number 1. Similarly, some volume of carbon dioxide gas would be getting produced from reaction number 2 as well. Have a look. Stoichiometric coefficient here is 1, here it's 4. I'll say when 1 liter butane undergoes combustion, 4 liters of carbon dioxide gas are produced. In the container, I did not have 1 liter of butane. I had 3 minus X liters. So when 3 minus X liter butane undergoes combustion, I would say 4 into 3 minus X liters of carbon dioxide gas gets produced. So this is the volume of carbon dioxide that is being produced from reaction number 2. Okay. My dear students, what is the total volume of carbon dioxide produced? 10 liters. Can I say volume of carbon dioxide produced from reaction number 1 plus volume of carbon dioxide produced from reaction number 2 should be equal to the total volume of carbon dioxide produced, that's 10 liters. Now tell me, what volume of carbon dioxide is produced from first reaction? 3x. Second reaction, it's 4 into 3 minus x is equal to what? Is equal to 10. So 3x plus 12 minus 4x is equal to 10. So x value comes out to be 2 liters. And what was this x? X was the volume of propane in the container which I was supposed to calculate. Is this particular question clear to everyone? Let me know once the chats, people. Is this particular question clear to everyone? Yes. Let me know once the chats, quick. Everybody. Everybody, people. Perfect, guys. Moving on to the next question. This is again your confidence booster. Tell me the answer of this question, quick. Sir, I said 2 liters first. Great. Tell me the answer of this one. A simple question this is. The number of spherical, angular, and total number of nodes in 3p. So, my dear students, we are given with 3p. How do we calculate the total nodes? My dear students, total number of nodes is given by the formula n minus 1. So, n value here is 3. So, I would say 3 minus 1 is equal to 2. So, total nodes are 2. Perfect. How do you get the angular nodes? Let me tell you, angular nodes are given by the value of L, azimuthal quantum number. What is the value of L for P? For P subshell, the value of L is 1. So, remember, angular nodes are going to be 1. They're asking us about the spherical nodes as well, right? You can call them as spherical or radial nodes. My dear students, spherical or radial nodes is given by the formula n minus L minus 1. So n value is how much? 2. L value is 1 minus 1. So this value is equal to 0, right? Did I do some mistake? Sorry. This is 3 here, okay? This is 3. 3 minus 1 minus 1. This comes out to be 1 here. Perfect. So these were the 3 things which you were supposed to calculate in this particular question as well. Correctly solved? Done and dusted? Yes, just the formula base 1 and you're sorted. Moving on to the next question, people. Number of molecules or ions in which the central atom is sp3 hybridized. In which the central atom is sp3 hybridized. Tell me quickly. What do you think about this one? Quick, quick, everyone. Everyone in the chats. What do you think? What do you think about this one? Everybody in the chats, people. The question is saying number of molecules. Number of molecules. Let me check one by one. Let me show you how do we deal with this sort of a question. First of all, let's talk about NO3 negative. Nitrogen is a central atom. How many valence electrons? 5. There is negative charge, so 5 plus 1 makes it 6. How many surrounding atoms? 3. So sigma bonds are 3. Right? Perfect. Now, oxygen is divalent. Right? So 6 valence electrons. Consider as if oxygen is making double bond. Consider as if all the oxygen atoms are making double bond. Consider as if all the oxygen atoms are making double bond. So how many bonds nitrogen will be forming then? 6. So can I say all the 6 valence electrons will be utilized to form 6 bonds? So there'll be no lone pair on nitrogen, right? So calculate the steric number. Steric number is sigma plus lone pair. So steric number is coming out to be 3. If steric number is 3, hybridization is sp2, right? It is sp2. Now, talk about this BCl3. Talk about this BCl3. My dear students, boron. Valence electrons, 3. Sigma bonds, 3. 3 valence electrons, 3 sigma bonds. So no lone pair on boron. Steric number, sigma plus lone pair 3. Hybridization, sp2. Perfect. ClO2 negative. ClO2 negative. Chlorine. How many valence electrons? 7. There is a negative charge. So plus 1 makes it 8. Surrounding atoms 2. So sigma bonds 2. Now I'm considering oxygen to form double bond. So how many bonds chlorine will be making then? I would say one oxygen makes 2 bonds. So 2 oxygen will make 4 bonds. So out of 8, 4 are utilized. Right? So 4 electrons are left as such on chlorine in the form of 2 lone pairs. So steric number is 2 plus 2, 4. Right? Hybridization will be sp3. Now, you have got next one, ClO3 negative. ClO3 negative. Chlorine, valence electron, 7. Negative charge, plus 1 makes it 8. Surrounding atoms, 3. So sigma bonds, 3. So one oxygen, we consider it forms a double bond. So chlorine will be forming 6 bonds. So out of 8, 6 valence electrons are used. So 2 will be left as such in the form of a lone pair. Steric number 3 plus 1, 4. And when steric number is 4, hybridization is sp3. What you were supposed to check? How many molecules do we see? How many molecules do we have with the hybridization sp3? So how many? How many people? Quick, quick, quick. This sp2, this sp2, this sp3, this sp3. Done? 2 molecules are there. Right? Amazing. Moving on to one more question, people. The equivalent mass of H2O2 in this reaction. The equivalent mass of H2O2 in this reaction. Understand how do I deal with this question. My dear students, if I ask you what is the oxidation state of oxygen here, I'll say it's -1 because it's hydrogen peroxide. Oxidation state of oxygen here is -2 and here oxygen is in 0 oxidation state. Now, -1 to -2, decrease in the oxidation state. -1 to 0, increase in the oxidation state. Can I say oxidation state of same element? Oxidation state of same element is increasing as well as decreasing simultaneously. Whenever you see oxidation state of same element increasing as well as decreasing simultaneously, we say this species undergoes disproportionation. And how do we calculate its n factor? Its n factor is calculated with the formula n1, n2 divided by n1 plus n2. Now tell me, what is n1, what's n2? See, how do I check it? -1 to -2. What is the change in oxidation state? Final oxidation state minus initial oxidation state. The value comes out to be 1. 1 is the change for one oxygen. I have 2. So 1 into 2 is 2. So n1 value is 2. Similarly, -1 to 0. What is the change in oxidation state? Final minus initial. The value is 1. 1 is the change for one atom of oxygen. I have 2. So n2 value is also 2. So I would say n factor would be equal to 2 multiplied by 2 divided by 2 plus 2. The value comes out to be 1. So my dear students, n factor of H2O2 is 1. If you got the n factor of H2O2, you can easily calculate its equivalent mass, which will be molar mass of H2O2 divided by its n factor. So 34 grams is going to be the equivalent mass of H2O2 in this particular reaction. Understood? I said first 34. Great, great, great. Perfect, people. Done with this one. Moving on to the next question. A simple one. A lot of students will make mistake here. Quick. Quickly, people in the chats. Quickly in the chats. Quickly in the chats. Quickly in the chats, everybody. Delta U is equal to isothermal work, isobaric work, adiabatic work, isochoric work. It's a simple question, guys. You know, as per your first law of thermodynamics is concerned, delta U is equal to Q plus W, right? Now, when can delta U be equal to W? I would say delta U can be equal to W only if Q is 0. Delta U will be only equal to W if Q is 0. In which process Q is equal to 0? That process is called as adiabatic process. That's called as adiabatic process. So in adiabatic process, Q is 0. So I would say in adiabatic process, delta U would be equal to W, right? Simple. So I can say delta U is equal to adiabatic work. Delta U is equal to adiabatic work. Done with this one? Perfect. Moving on to one more. Look at this one. Look at this one, people. Look at this one. Quick in the chats. So duration will be 1.5 hours, as I told you. I'll be very quick today. See, guys, standard entropy of x2, y2 and xy3 is given to us. All right. The reaction is given. Its delta H is given. We have to calculate the temperature at which the reaction will be at equilibrium. We have to check at what temperature the reaction will be at equilibrium. My dear students, for the reaction to be at equilibrium, delta G has to be 0. Now, what is delta G? That is delta H minus T delta S. This has to be equal to 0. Now, delta H is given to me. But delta S, entropy change of the reaction, is not given to me. How do I calculate entropy change of the reaction? Entropy change of the reaction is nothing but entropy of products minus entropy of reactants. So, entropy of products, stoichiometric coefficient here is 1. Entropy of xy3. So, this is entropy of products minus entropy of reactants. Here the stoichiometric coefficient is 1/2 and entropy of x2 plus this is 3/2 times entropy of y2. Put the values, my dear students. What is the entropy of xy3? Entropy of xy3 is given to me as 50 minus this is 1/2 times entropy of x2 is given to me as 60, right? Plus 3 divided by 2 times entropy of y2 is given to me as 40. Now do a bit of calculation here. This is 50 minus this will be 30 plus this is 60, right? So 60, 30 is 90. So the value comes out to be minus 40 joules per Kelvin. This is the delta S which you have calculated. This is the delta S which you have calculated. Now put the value of delta S as well as delta H here. What is the value of delta H that's given to us? That is minus 30 kilojoules. Since delta H is in kilojoules, here delta S I got in joules. So convert this kilojoules into joules as well. So I would say delta H is equal to minus 30,000 joules minus T into delta S. Delta S is minus 40. Minus is plus. So it is 40 times T is equal to 0. Right? Perfect. Simple. Now take this 40T on that side. Or I would say simply 40T has to be equal to 30,000. Or I would say temperature should be equal to 750 Kelvin. Right? So I would say this particular reaction should proceed at 750 Kelvin. Then only I would say this particular reaction will be at equilibrium. Perfect. Done with this? I believe this particular sort of question is clear to everyone. At what temperature the reaction is at equilibrium? And you got to know at 750 Kelvin, this particular reaction will be at equilibrium. Frequently asked questions in your NEET examination. Moving on to the next one. Look at this one, guys. We are given the reaction XA gives YB. XA gives YB. This X and Y, these are the stoichiometric coefficients of reactants and products. Now, first of all, my dear students, what would be the rate of the reaction with respect to A? I'll start with minus 1 divided by stoichiometric coefficient is X. Change in the concentration of A divided by delta T is equal to rate of reaction with respect to B. Start with the plus sign. 1 divided by stoichiometric coefficient. Change in the concentration of B divided by time interval delta T. Right? Now, if you look at the given data, this given data, this term is in log, this term is in log, this term is not in log. Right? So let's do one thing. Let's convert this term also in log. So I'll write log of minus delta A divided by delta T is equal to log of delta B divided by delta T. And you know 0.6 is nothing but that's log of 4. That is log of 4. 0.6 is nothing but log of 4. Now people, tell me one thing. Log of minus delta A divided by delta T is equal to log of M plus log of N. Log of M plus log of N is log of M into N. So I'll write 4 first. Then I'll write delta B divided by delta T. Perfect. So if I take anti-log on both the sides, so it will be minus delta A divided by delta T is equal to 4 times delta B divided by delta T. Now we can do one thing. If I take this 4 on the denominator here, it will be minus 1 by 4 delta A divided by delta T is equal to delta B divided by delta T. Now, my dear students, if I compare the two equations, the equation which we already made and the equation which is here, when you compare these two equations, I'll get to know x value is nothing but equal to 4, x value is equal to 4, and y value is nothing but this 1 by 1 here, y value is equal to 1. And this x and y I was supposed to calculate. Perfectly done? Yes or no in the chats? Perfectly done? Amazing. Now, people, moving on to the next question. What do you think about this one? The slope of ln k versus 1 by t, ln k versus 1 by t for a first order reaction is given. Calculate activation energy in kilojoules. I hope you know this result. Ln of k is equal to, ln of k is equal. Do you know the result? Ln of k is equal to ln of a minus EA divided by R multiplied by 1 by t. This is one of the results of Arrhenius equation. This is one of the forms of the Arrhenius equation. This is one of the forms of the Arrhenius equation. Now, my dear students, if you plot a graph between ln k versus 1 by t, if you plot a graph between ln k versus 1 by t, this becomes your m, the sign is minus, and this becomes c. So the graph is going to be y is equal to minus mx plus c. The graph is going to be, if you plot a graph between ln k versus 1 by t, the graph is going to be y is equal to minus mx plus c, something like this, right? So its slope is nothing but minus EA by R. Its slope is nothing but minus EA by R. And this slope is given to me in the question. How much is that? Minus 5 into 10 raised per minus 3. Sorry, 10 raised per 3. Perfect. So minus cancels out. So when minus cancels out, I'll say EA is equal to 5 into 10 raised per 3 multiplied by R. Right? Now, people, I have to calculate activation energy in kilojoules. So I'll write 5 into 10 raised per 3. R value, I'll take 8.314 joules per Kelvin per mole. But I need the answer in kilojoules. So dividing this with 1000, I'll be getting the answer in kilojoules here. Right? Like this question can be framed too. I believe this is clear. Yes? Done, people? Done. Everyone in the chats? Everyone in the chats, quickly. Yes or no? Moving on to the next question, people. Moving on to the next question. Look at this question, guys. A reaction is given, its E value is given. One more reaction is given, its E value is given. One more reaction whose E value is to be calculated. One more reaction whose E value is to be calculated. So basically, this is your equation number 1, this is equation 2, this is equation 3. My dear students, I am supposed to make equation 3 from 1 and 2. I am supposed to make equation 3 from 1 and 2. Now think over it. How can you make 3 from 1 and 2? Just do one thing. 3 can be made simply like this. How? Equation 1 plus equation 2. When you add 1 and 2, this term gets cancelled out. It becomes copper dye positive plus 2 electrons gives copper. Right? So third equation is being made by when first and second is being added. Now whatever operation you are doing with the reactions, whatever operation you have done with the reactions, same operation, my dear students, you are going to do with their delta G values. Remember that. Whatever operation you are going to do with your, just a second. It's very hot. So what I'm trying to say is whatever operation you are doing with your reaction, same operation you are going to do with their delta G values. What you are going to write? You'll write delta G for the third reaction is equal to delta G for the first reaction plus delta G for the second reaction. Now, my dear students, I believe all of you would be knowing about one thing. Delta G is nothing but minus NF E cell. Delta G is nothing but minus NF E cell. So, delta G3 is minus N3FE3 is equal. Delta G1 is minus N1FE1. Delta G2 is minus N2FE2. So, first of all, F everywhere cancels out. When you multiply with minus, finally you get the E3 value something like this. N1E1 plus N2E2 divided by what? Divided by N3. Now you must be thinking, E1, E2 given to me in the question. Now N1, N2, N3, what are these values? My dear students, this is your N1, that's 1. N2 value is also 1. N3 value is 2. Right? So N1 into E1, N1 into E1, N1 into E1. Perfect. So 1 into 0.15 is 0.15 plus N2 into E2, that's again 0.5 divided by N3. N3 is 2. Solve this, get the answer. That's it. Perfect, people. Am I clear with this? Everyone, just one thing you have to remember. Whatever operation we do to the reactions, same operation is to be done with the delta G values. That's all. Okay? Perfect. Amazing. Moving on to one more question. Which will be comparatively lengthy question. Look at this one. My dear students, I am given with a cell. It is a complete galvanic cell. Its E cell is given. Concentration of M di positive divided by this is given as 10 raised per x. We have to calculate x if E naught is equal to this. Okay? Now see, how am I going to approach to this sort of equation? First of all, this is your salt bridge. On the left side of the salt bridge, what do we have? We always have anode, right? And at anode, what happens? Oxidation takes place. Your H2 gets converted into H positive. So I would say H2 gas will be getting converted into 2 times H positive aqueous. And with that, you'll be writing 2 electrons. This will be the reaction taking place at anode. At anode, oxidation takes place, loss of electrons, right? Now, reaction at cathode. M plus 4 getting converted into M di positive. So I would say M plus 4 aqueous would be gaining 2 electrons and then getting converted into M di positive aqueous. Now tell me one thing. Are the electrons balanced in both the reactions? Yes. So add the 2 reactions. When you add the 2 reactions, these 2 electrons gets cancelled. So N value I got to know first of all as 2. Now, my dear students, what is my net reaction? My net reaction will be something like this. H2 gas plus M plus 4 aqueous. What does it give me? It gives me 2 times H positive aqueous. And with this, I'll be writing M di positive aqueous. Perfect. This is my net reaction after adding these 2. Now, if I ask you, what would be the reaction quotient? Reaction quotient is nothing but that will be equal. Concentration of H positive. How much is that? That's 1. 1 raised per anything is 1. Multiplied by concentration of M di positive. Divided by H2. H2, its pressure is 1. Concentration of M plus 4. This is the QC expression. Now, people, if you look at the question carefully, M di positive divided by M plus 4. M di positive divided by M plus 4. That's equal to 10 raised per x. Given to me in the question. Now, what is E naught cell? E naught cell will be equal to E naught cathode minus E naught anode. So, tell me what is the SRP of cathode? This is your SRP of cathode, which is given to me as 0.151. Minus SRP of anode. Anode is hydrogen electrode. And for hydrogen electrode, SRP is 0. So, I got the E naught cell as well. I got the N value, I got the QC value, I got the E naught cell value. Now, I'll have to use the Nernst equation. My dear students, when I use the Nernst equation, I'll say E cell is equal to E naught cell minus 0.0591 divided by N, and it's going to be log of QC. This is your Nernst equation. Now, E cell is given to me in the equation, 0.092. E naught cell we got, that is 0.151 minus 0.0591 divided by N value is 2, and it's log of QC. How much is QC? 10 raised per x. When you solve this equation, you'll get the x value as 2. When you solve this equation, you'll get the x value as 2. Done and dusted, right? Perfect. So reaction at anode, reaction at cathode, net reaction, N value, QC value, E naught cell, then use the Nernst equation and you're sorted. Perfect. I'm moving on to one more question. This question will be asked only if the paper comes out to be difficult. Okay? Not under the usual conditions, this sort of a question will be asked. As I told you in the beginning, I have kept easy, moderate, as well as some difficult questions. Okay. Look at this one, people. Look at this one. My dear students, as far as this question is concerned, your K2Cr2O7, is reacting with Xn positive, and converting this Xn positive into XO3 negative. Since the reaction is taking place in acidic medium, and you must know in acidic medium, K2Cr2O7 gets converted into Cr tri positive. Your K2Cr2O7 is converting Xn positive into XO3 negative. And in acidic medium, K2Cr2O7 itself gets converted into Cr tri positive. Now tell me one thing. How many moles of K2Cr2O7 are given? 6 into 10 raised power minus 3. How many moles of this Xn positive are given? That's 9 into 10 raised power minus 3. Now tell me, what is the N factor of K2Cr2O7 in acidic medium? You should remember this. N factor of K2Cr2O7 in acidic medium is 6. Now, what about the N factor of this particular species? Have a look. Oxidation state of X is here plus N. Here, X is in plus 5 oxidation state. So, final minus initial. So, it's 5 minus N. Its N factor is N. Now, if you just use the equivalent concept, I'll say the equivalence of K2Cr2O7 reacted is equal to the equivalence of Xn positive. Or in short, I can write something like this. N1 multiplied by N factor 1 is equal to N2 multiplied by N factor 2. Right? What is N1? That is 6 into 10 raised power minus 3. What is N factor 1? That is 6 is equal to N2 is 9 into 10 raised power minus 3 multiplied by 5 minus N. Perfect. So this 10 raised power minus 3, this 10 power minus 3 cancel. 6, 6, 36. 36 divided by 9 is 4, right? Which is 5 minus N. Right, people? So N value will be equal to 1. That's it. And what was this N? N was basically the charge present on this X, which you were supposed to calculate. Right? Perfect. N value will be equal to 1. Just use this formula. N1 into N factor 1 is equal to N2 into N factor 2. Whenever you see this sort of a question, you'll be done and dusted with this. Yeah? Moving on to the next question, people. Tell me the answer of this one. Tell me the answer of this one. What transition in hydrogen spectrum? What transition in hydrogen spectrum would have same wavelength as the Balmer transition? N is equal to 4 to N is equal to 2 in He positive. In He positive. So basically, in He positive, the electron is making a transition from 4 to 2. In He positive, the electron is making a transition from 4 to 2. So this is the lower energy state. This is the higher energy state. So definitely when electron will be making a transition from higher to lower, it will be emitting energy in the form of radiation. That radiation will be having some wavelength. That radiation will be having some wavelength. Now the question is asking, what should be the transition in hydrogen? What should be the transition in hydrogen such that the wavelength emitted is equal to lambda? Here, when the electron is making a transition from 4 to 2, it will be emitting some wavelength. That's lambda. So what should be the transition in hydrogen spectrum such that electron emits the same wavelength lambda? What you'll be doing? You'll be using the Rydberg's formula. What is the Rydberg's formula? 1 by lambda is equal to R Z square 1 upon N1 square minus 1 upon N2 square. So use the Rydberg's formula for hydrogen first. So 1 divided by lambda is equal to R. Z value for hydrogen is 1. Atomic number is 1. 1 upon N1 square minus 1 upon N2 square. Use the Rydberg's formula here. It's going to be 1 divided by lambda is equal to R. Z value for helium, hydrogen, helium 2. So 2 ka square is 4, right? 1 upon N1 square, 2 ka square is 4, minus 1 upon N2 square, 4 square is 16, right? So it can be written as 1 by lambda is equal to R. This will be 4 gets cancelled, so it's 1 by 1, minus 1 by, this will be 4. Perfect. Or you can further write it as 1 by lambda is equal to R. This you can write as 1 by 1 square, minus 1 by 2 square. Now, my dear students, if you compare these two equations, just compare these two equations. When you compare these two equations, you get to know N value is nothing but 1, N value is nothing but 1, and N2 value is nothing but 2. N2 value is nothing but 2. So I would say in case of hydrogen, electron has to make a transition from 2 to 1. In case of hydrogen, electron has to make a transition from 2 to 1. Then only it's going to emit the same wavelength as was emitted by the electron when it was making the transition from 4 to 2 in case of He positive. Right? Perfect, people. Perfect. Everyone in the chats. Everyone in the chats. Yeah? Everyone in the chats. All right. A simple question. Give it a try. Give it a try, people. Everybody. Reaction is given. We have to get the ratio of Kp and Kc. Now, first of all, calculate delta Ng for the reaction. Delta Ng is number of moles of gaseous product, that is 1, minus number of moles of gaseous reactant, that is 1 plus 1 by 2. So this particular value comes out to be minus 1 by 2. So this is your delta Ng. Now, you know, your Kp is nothing but, that is Kc, RT raised by delta Ng for the gaseous phase reaction. So I would say Kp divided by Kc is nothing but, it is RT raised by delta Ng is how much? Minus 1 by 2. So you can write as 1 divided by square root of RT. 1 divided by square root of RT. That's option, last one. Done? Are you done with this? Did you understand, people? If it is clear to everyone, let me know once in the chats, quickly in the chats. I am moving on to the next question. Look at the question, people. Look at the question carefully. You are given the reaction, okay? You are given the reaction. What do we have to calculate? We have to calculate Kp for the reaction. We need to calculate Kp for the reaction. How do we calculate Kp? How do we write the expression for Kp? I would say Kp for the reaction is nothing but it'll be partial pressure of NH3 at equilibrium raised power 2 divided by partial pressure of N2 at equilibrium raised power 1 multiplied by partial pressure of H2 at equilibrium raised power 3. That's how you write Kp expression. Now people, see, all the things are given to me in the question. Partial pressure of N2 at equilibrium is given, H2 is given, right? First of all, you should know one thing. When equilibrium is established in the reaction, at equilibrium, how many gases will be there in the container? 3 gases. At equilibrium, there will be 3 gases in the container. So I would say there will be a mixture. There will be a mixture of 3 gases present in the container at equilibrium. And total pressure of the mixture at equilibrium in the question is given to be as 2.8 atm. And you know total pressure of the mixture is nothing but that will be partial pressure of N2 at equilibrium plus partial pressure of H2 at equilibrium plus partial pressure of NH3 at equilibrium. This is equal to 2.8. This value is given. How much? 0.8. This is 0.4. So you can calculate partial pressure of NH3 from here. That will come out to be 1.6. Now put the values. This is 1.6 ka square divided by partial pressure of N2 at equilibrium is 0.8. Partial pressure of H2 at equilibrium is 0.4 raised power 3. When you solve, the value comes out to be 50. That's it. Yes? Perfect, people. I believe this sort of a question is clear. And if it is clear, if it is clear, if it is clear, tell me the answer of this question. Tell me the answer of this question. Quickly in the chats, tell me the answer of this question. After me, KK will be joining in for organic. Yes. Quick, quick, quick. Calculate the ionization constant of a weak base NH4OH. So tell me NH4OH, it's a weak base. And how it undergoes ionization. It undergoes dissociation as NH4 positive aqueous. And with that, you write OH negative aqueous. Right? Now, my dear students, initially at time t is equal to 0, the concentration of NH4OH is given to me in the question, I believe. How much? I'll calculate the ionization constant of the weak base NH4OH if the concentration of OH negative in 0.1 molar solution. So its concentration is given to me as 0.1. This would be 0. This would be 0. Now at equilibrium, if the degree of ionization is alpha, so this is supposed to be C minus C alpha. This would be C alpha. This would be C alpha. Now, my dear students, if you write the expression for ionization constant of the base, it's going to be C alpha square divided by 1 minus alpha. C alpha square divided by 1 minus alpha. This how you calculate the ionization constant of this weak base. Now the point is one thing. The point is one thing. Concentration of OH negative in the final solution. That means concentration of OH negative at equilibrium is given to me in the question. How much? That is 0.05. Concentration of OH negative in the final solution is given to me as 0.05. Now, as per our calculation, concentration of OH negative is nothing but C alpha. So C alpha is 0.05. I'd say alpha is equal to 0.05 divided by C. What is C? 0.1. So alpha value is coming out to be 0.5. Alpha value is coming out to be 0.5. Now put the value of C and alpha here. C is 0.1. Alpha ka square. So 0.5 ka square. 1 minus alpha. 1 minus 0.5 is 0.5. 0.5 cancels out. The value comes out to be 0.05. So this is your dissociation constant or ionization constant of the weak base, which you were supposed to calculate. Done? Amazingly done. Look at this one. Calculate the solubility of mercurous chloride. Mercurous chloride formula is Hg2Cl2. Now remember this Hg2Cl2. It undergoes dissociation in a special way. How? Mercurous chloride dissociates like this. Hg2 di positive plus 2 times Cl negative. This is how it dissociates. This is how it dissociates. If its solubility is S, this will be S, this will be 2 times S. Because the stoichiometric coefficient here is 2. Here it was 1. Now, if you want to write the KSP expression, KSP is simply going to be concentration of Hg di positive, that's S, raised power stoichiometric coefficient 1. Concentration of Cl negative, that is 2S, raised power stoichiometric coefficient 2. So the value comes out to be 4S cube. So I would say S is nothing but KSP divided by 4 whole raised power 1 by 3. Now what is KSP? KSP is 10.8 into 10 raised power minus 23 divided by 4 whole raised power 1 by 3. So what you can do is, you can make it as 108 into 10 raised power minus 24 divided by 4 whole raised power 1 by 3. This comes out to be 27 into 10 raised power minus 24 whole raised power 1 by 3. This comes out to be 3 into 10 raised power minus 8 moles per liters. So this is the solubility of mercurous chloride in water. Yes? All right. Tell me the answer of this question. Quick. The correct order of second ionization energy. You have to give me the order of ionization energy, people. You have to give me the order of second ionization energy, not the first one. Second ionization energy. What do you think? You have to give me the order of second ionization energy. Quick, 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 quick. Second ionization energy, people. Oxygen will have more second ionization energy. Because if I talk about the second oxygen energy, if I talk about the second ionization energy, initially its configuration was 2p4. Now you have already taken one electron out. Now it's 2p3. So to take electron out from the half-filled configuration, you have to supply more energy. So the second ionization energy of oxygen is maximum among all, right? Followed by what? Followed by fluorine. Then comes nitrogen, then comes carbon. So this is your option A. This is your option A. They are talking about the second ionization energy. Just guys, I have 3 more questions and we are done. After that, your organic session will start. Which of the following represents correct trend? Which of the following represents correct trend? It is more than one option correct. Which of the following represents correct trend? More than one option. First ionization energy. Chlorine, phosphor, sulfur, boron. This is correct. Electron affinity of chlorine is more than that of fluorine. This is correct. Metallic character. Potassium, aluminum, magnesium. After potassium, magnesium should come. Then aluminum should come. So this is incorrect. These are all your, okay, basic character. K2, Ne2, Mg. This is correct. All the 3 are correct. Right? Look at these trends afterwards. Tell me the answer of this one. Pair of species having same bond order as well as paramagnetic. Which of the following species have same bond order as well as are paramagnetic? Well, if you look carefully, same bond order. Isoelectronic species, they have got same bond order. Isoelectronic species, they have got same bond order. O2 positive. In O2, 8, 16. 16 minus 1, 15 electron species. 7 2s are 14 plus 1, 15 electron. So they are isoelectronic. Same electrons. Their bond order will be same. Right? And since there are 15 electrons, they'll be paramagnetic as well when you write their molecular orbital configuration. Okay? The last question, people. The last question. XeO2F2. Let me call KK sir. I'll just check if he's ready. Sir, Tushu ready? Okay, I'm at the last question now. Okay. Quickly guys, give this a try. XeO2F2. XeO2F2. First of all, let's get to know what shape this has. XeO2F2. Xenon, central atom, 8 valence electrons. How many surrounding atoms? 4. So there are 4 sigma bonds, right? There will be 1 lone pair on xenon. So 4 sigma bonds, 1 lone pair. Steric number will be 4 plus 1, 5. The type of the molecule is AB4L1. Hybridization will be sp3d. Shape of the molecule is going to be seesaw. And how it looks like, the seesaw molecule. This is Xe, right? This will be F. This will be F, right? Xe, O2 and F2, right? This is O. This is O. And here you'll have a lone pair. This is its structure. XeO2F2. Okay? This is the structure. Now, check it out. Which are not true? Not true. This is true. Seesaw shape. This is true. So this is not my answer. This is true. Okay? OXE bond angle. OXE bond angle. OXE O bond angle is closer to 180. Is it closer to 180? No. This is wrong. FXEF bond angle. FXEF bond angle is closer to 180. That's correct. So there is only, this is correct one, right? I don't have to select the correct one. I have to select the incorrect one. So it's only option B. Perfect. I believe this was clear. And guys, like I posted one session today in the morning, that was 100 marks in 25 minutes. Tomorrow morning, again, I'll be sharing the similar session. Again, 100 marks in just 20-25 minutes. Do watch that. And day after tomorrow, it's going to be a combined session of me and KK sir again, in which we shall be discussing your complete chemistry in 180 MCQs in total. So do join that particular session as well, right? Wishing you all the luck. Now start with KK sir. He'll be completing your organic in just 20 to 25 minutes. Okay? Take care, guys. God bless you all. Bye-bye.
Good evening, everyone. I know you guys are super excited for writing your one of the most prestigious exam on this Sunday. But before doing that, let's do some mock drill here to, practice some super exciting questions. But before that, before we move ahead, let me know in the chats quickly. Let me know in the chats quickly if I am audible and visible to each and everyone. Let me know quickly. Let me know quickly if I am audible and visible to each and everyone. Okay, so without wasting time, let's begin. Let's begin. Our first question is that X is the product which is obtained by hydrolysis of prop-1 ion. Have a look. This is prop-1 ion. This is prop-1 ion. You have to tell me that if we do hydrolysis of this in presence of HgSO4, H2SO4 and at a temperature of 333 Kelvin, what will happen? Here it will be simply hydration reaction and it will result in the formation of acetone. So this is our X. Now, X is the product which is obtained by hydrolysis of this in presence of mercuric sulfate under dilute acid medium at 333 Kelvin. Why is the product which is obtained by reaction of ethane nitrile? This is ethane nitrile. This is ethane nitrile. Have a look, have a look. Okay, with methyl magnesium bromide. Okay, in dry ether, that means solvent here is dry ether, followed by hydrolysis. Now, what will be the product over here? Product here will be once again an acetone, you know that. So this is, RY. Okay. Now, what is the IUPAC name of the product obtained from X and Y? X and Y in the presence of barium hydroxide. That means when you treat acetone with acetone, that means here in presence of barium hydroxide, BaOH whole 2, and then heat. Which type of reaction is this? This is simply self-aldol condensation reaction. So water will be lost and we will get CH3, CH3, double bond CH, single bond C, double bond O, single bond CH3. This is the functional group. So if we number this parent chain, this is 4-methyl, so its name is 4-methyl. After that, it's having 5 carbons, so pent. After that, this is having double bond at 3 position, so 3N, and then it is 2-on. So this is the IUPAC name of this product. So have a look. So what will be the answer of this question? It is 4-methyl pent 3N, 4-methyl pent 3N, and 2-on. That means it is option number 2. Let me know in the chats if this is clear to each and everyone. Let me know quickly. Is this clear to each and everyone? Let me know quickly. Is this clear? Is this clear? First, it is hydration reaction simply of alkyne known as Kocharov's reaction. Then it is this methyl magnesium bromide which will attack over here. That means nucleophilic addition followed by hydrolysis resulting in the formation of acetone. Then this acetone in presence of barium hydroxide and heat, it undergoes what we call self-aldol condensation reaction, resulting in the formation of this one. Okay, so this is question number 1. After that, question number 2 is like this. Paper chromatography is an example of, remember, paper chromatography is an example of partition chromatography. It is simple question. Now, after that, question number 3 is, an optically active alkyl bromide having a formula C4H9Br. Remember, C4H9Br is having 4 structural isomers. Among one, optically active is this one, CH3, CH2, CH, then CH3, and this is what we call Br. So this is C4H9Br, which is optically active. When it reacts with ethanolic KOH, that means when it reacts with alcoholic potassium hydroxide, remember, this is always E2. It undergoes, this alkyl halide in presence of this undergoes E2 reaction. So this is alpha, this is beta. We know major product will be from this beta. ZF will be the major product. So remove beta hydrogen and remove alpha, this Br, and you will get this one. You will get but2ene. So this is what we call compound A. After that, this compound on reacting with bromine to give compound B. Now, if it is treated with bromine, what will happen? Addition of bromine will take place across carbon-carbon double bond. So bromine will be added across carbon-carbon double bond, and this is anti-addition reaction, so we will get product B. After that, this B reacts with alcoholic potassium hydroxide once again. Alcoholic potassium hydroxide once again undergoes what we call E2 reaction, followed by a sodamide, once again an E2 reaction. That means 2 consecutive E2 reactions will take place, and it will result in the formation of an alkyne like this. It will result in the formation of an alkyne, and this is C. 1 molecule of water. After that, you have to add 1 molecule of water to this, and we know water is added, OH will go to this, H will go to this. After that, enol formation takes place and it will tautomerize, and finally we will get CH3CO, CH2, CH3. That means our product will be, this D will be simply a ketone. And after that, it is this product D, the functional group in this D will be confirmed by, this ketonic functional group is confirmed by haloform reaction. We know, because whenever you are having CH3CO in aldehyde or ketone, that will show haloform reaction or haloform test. Lucas test, that is test to distinguish primary, secondary and tertiary alcohols. That means this is not the option. Silver mirror test, that means it is shown by aldehydes, not by ketones. Similarly, Benedict's test is shown by aldehydes, not by ketones. So option number 1 is the right answer. After that, given below are 2 statements. Statement 1 is, in this structure, the carbocation is stabilized by OCH3 group. This is exactly correct. After that, in statement 2, carbanion is stabilized by minus R effect. That's also correct. That means both statement 1 and statement 2 are correct. After that, consider the following organic reaction sequence. Choose the final product X. You have to choose this one. Now have a look. Whenever this acid is treated with this one, say ammonia followed by, heat, it always results in the formation of this COOH group is changed. This COOH group is converted to CONH2 group. That means it will result in the formation of amide first. After that, when it is treated with what we call NaOH Br2. This is Hoffman bromamide reaction. This C double bond O will be lost. C double bond O will be lost. So it will result in the formation of C double bond O will be lost. So it will result in the formation of this ethyl amine. After that, this is treated with HNO2 and H2O at a temperature of 0 to 5 degrees Celsius. Remember, we know aliphatic primary amines are converted to alcohols with the help of this reaction. So we will get CH3, CH2, or what we call OH, CH3, CH2, 1, 2, 3. Now, give me a second. It is like this. 1 carbon is lost over here. So it is CH3, CH2, and this is what we call NH2. This is CH3, CH2, and then it is OH. It is ethanol. Ethanol on treatment with benzene diazonium chloride. Ethanol on treatment with benzene diazonium chloride at 0 to 5 degrees Celsius. What will happen? This N2 will be replaced by hydrogen when it is ethanol. So it will result in the formation of benzene. Simple answer. It is this one. It is benzene. Now let me know quickly. Let me know quickly, is this clear? Let me know quickly, is this clear? It's first one, not phenol, not phenol. Whenever you are having benzene diazonium salt treated with either H3PO2 and water or ethanol, this N2 will be replaced by hydrogen. That means we will get, when hydrogen will come instead of this N2, we will get what we call benzene. After that, try to answer this question. This is very, very, very easy question. Now, we know during this reaction what will happen. It will result in the formation of phenol. One of the products will be phenol and another product will be benzyl iodide. Another product will be benzyl, iodide. Have a look, have a look. That means this bond will be broken. I will go to this, H will go to this. Now, look towards the options. Statement 1. In the above reaction, product formed will be a mixture of benzyl alcohol and iodobenzene. No, it is benzyl iodide and phenol. Statement 1 is incorrect. In the above reaction, OCH2 bond is cleaved. OCH2 bond is cleaved to give the product. This is exactly correct. So statement 1 is incorrect and statement 2 is correct. Statement 1 is false and statement 2 is true. It is this one. Statement 1 is false and statement 2 is exactly true. Now after that, the number of compounds from the following which can undergo reaction with Br2KOH. Let me tell you, Br2KOH means Hoffman bromamide reaction. After that, give respective product. That means which among these can show Hoffman bromamide reaction. Have a look. This can show Hoffman bromamide reaction. This can show Hoffman bromamide reaction. This can also show Hoffman bromamide reaction because primary amides show Hoffman bromamide reaction. This can show Hoffman bromamide reaction. This cannot show, this cannot show. But during Hoffman bromamide reaction, what happens? This C double bond O will be lost and it will result in the formation of aniline. It will result in the formation of C6H5CH2 NH2, benzylamine. It will result in the formation of CH3 NH2. It will result in the formation of C6H11 and NH2. But remember, this aniline is not obtained. Aniline is not obtained as per Gabriel-Thalymide reaction is concerned. That means this will not give Gabriel-Thalymide reaction. Gabriel-Thalymide reaction is not possible during that reaction. It's not possible to form what we call aniline. Now, this will be formed, this will be formed, this will be formed. In nutshell, both reactions, during both reactions, what will be the product? This will be the product, this will be the product, this will be the product. This will be the product during Hoffman bromamide, but not Gabriel-Thalymide. That means these three will be the products which, these three are the, products which can be obtained by both Hoffman bromamide reaction as well as Gabriel-Thalymide reaction. So 1, 2 and 3. 3 is the right option. After that, we will be having another question, a very, very important question. Now, this is CHOH whole 4 and then CH2OH. This is CHOH whole 4. This is CHOH whole 4. Now, tell me what will happen. When it is treated with CHI after heat, we will simply get this one. We will simply get, this will be converted to CH3, this will be converted to, CH2, then this will be converted to CH3. In nutshell, we will get N-hexane. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. We will get N-hexane. We will get first N-hexane. Now, this upon treatment with this oxidizing agent undergoes cyclization and then aromatization. In nutshell, this is aromatization reaction, and we know the product formed from N-hexane during aromatization is benzene. So product formed is benzene. After that, benzene on treatment with benzoyl chloride. Benzene on treatment with benzoyl chloride is this one. Very, very simple question. What will happen? It is simple benzylation reaction. So benzylation reaction will take place and it will result in the formation of benzophenone. It will result in the formation of benzophenone. Now look towards this benzophenone. How many pi bonds are there? 1, 2, 3, 4, 5, 6, 7. 7 pi bond. And each pi bond contains 2 pi electrons. That means 14 pi electrons in 7 pi bonds. And in addition to that, 4 electrons in the form of 2 lone pairs. In total, lone pair of electron as well as these pi bond electrons, in total they are 2, 4, 6, 8, 10, 12, 14, 16 and 18. So 18 is the right answer. Let me know quickly, am I clear till now? Let me know quickly, am I clear till now? Let me know quickly. Let me know quickly, am I clear till now? Am I clear till now? Exactly at the rate of Hershey. It's 18. Exactly. It's 18. Yes, at the rate of Austin. It's 18. After that, we will be having another question. It's a statement-based question. Methane can be prepared by decarboxylation of sodium ethanoate. This is sodium ethanoate. Sodium ethanoate is this one. Yes, due to decarboxylation by using soda lime, we can get what we call, here we will form this one, this will be removed, this CH3 and H will form CH4. Yes, this is true. Now after that, Kolb's electrolysis. No, never. Because this is sodium acetate. Kolb's electrolysis. During Kolb's electrolysis, methane is not obtained because it will result in the formation of a radical that undergoes coupling or combination, and it will result in the formation of ethane. So methane is not formed during this. That means statement first because of this is false. After that, methane cannot be prepared from unsaturated hydrocarbons. That is true, because unsaturated hydrocarbon is, say for example, alkene or alkyne. They contain at least 2 carbon atoms, and methane contains only 1 carbon atom. That clearly indicates that methane cannot be prepared from unsaturated hydrocarbon, as well as methane cannot be prepared by normal Wirtz reaction. This is true. That means statement 1 is false, but statement 2 is exactly true. So it is option number 4. It is option number 4. It is option number 4. Let me know quickly. Is this clear? Is this clear? At the rate of Nargis Nabi, exactly it's 4. At the rate of Rakesh, exactly 4. At the rate of Delvin, Harshi, exactly. Everyone is correct. Everyone is correct. After that, we will be having another question. First of all, have a look. It is ethyl and NO2 attached to benzene ring. Ethyl is ortho-para-directing and activating group. This is what we call meta-directing, means this is deactivating group. We know these two can form what we call Br positive. This is electrophilic substitution reaction. And whenever you are having ortho-para-directing, that means one activating group, another deactivating group. Now, the electrophile, position taken up by the electrophile in the ring will be decided by ortho-para-directing group or activating group. That means this Br positive will go to either ortho or para position with respect to ethyl, but para position is blocked. That's why this electrophile will go to ortho position. So our product will be like this. It will be CH2CH3. Let me write down over here. Let me write down this over here. So A will be simply like this. A will be simply like this. It will be C2H5 and it will be NO2, and electrophile will go to ortho position with respect to activating group. So this is A. After this, my dear students, this on treatment with SnHCl. This is a reducing agent. It will reduce NO2 to NH2. So it will form an amine over here. So C2H5Br remains unaffected and this NO2 is converted to NH2. So this is RB. After that, NaNO2 HCl, NaNO2 and HCl at a temperature of 273 to 278 Kelvin. That means 0 degree to 5 degree Celsius. This NH2 will react with this. This is diazotization reaction and we will get diazonium salt. We will get diazonium salt. Have a look. We will get diazonium salt like this. We will get diazonium salt like this. After that, once again, it is ethanol. Ethanol on treatment with diazonium salt. It will replace this N2 by hydrogen. So we will get like this. We will get like this. This N2 will be replaced by hydrogen. Finally, this undergoes, so this is, I mean to say C, this is, I mean to say D. After that, it's undergoing oxidation. Oxidation of alkyl group will take place, followed by, I mean say first it will result in the formation of CO minus and K positive, and then this is undergoes acidification or hydrolysis. Finally, ethyl group is changed to COOH and it will become this one, 2-bromo-benzoic acid. It will result in the formation of, let me write down this, 2-bromo-benzoic acid will be the product. 2-bromo-benzoic acid will be the product. So this is Re. This is Re. So E is 2-bromo and this is 2-bromo and 4-nitro. Now have a look. A is this one, A is this one and E is this one. I hope this is clear. I hope this is clear. Very, 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 very easy. Exactly, B is the right answer. After that, this is very easy. This is very easy. I will be waiting for the answer of this question. Let me know in the chats. I am not going to show this question until and unless you will answer the question. Come on, because this is very easy. This is very easy. Match the column. Match the column. This is benzene diazonium salt on treatment with CuCl, that means cuprous chloride. Which type of reaction is this? This is Sand-Meyer reaction. This is Sand-Meyer reaction. That means A is 4. A is 4. That means our option number 1 will be the right answer. A is 4. Option number 1 will be the right answer. This is CuCl. That means A is Sand-Meyer reaction. This is copper powder. That means B. B is what we call Gutterman reaction. That means B is 3. After that, this is Bals-Schimann reaction. That means C is 2. So A4, B3, C2. And after that, this is coupling reaction with phenol. So this is D1. So it is obviously option number 1. Option number 1 is the right answer. After that, you have to tell me which of the following is aromatic. This is very, very, very simple. So this is aromatic. This is aromatic. This is very easy. This is very, very, very easy. Let me mark by black color because this is not visible. So I'm marking the answer with black color. So B is aromatic. This is not aromatic because of this sp3 hybridized carbon, sp3 and sp3, because complete cyclic conjugation is absent in this, complete cyclic conjugation is absent in this, as well as in option number D. After that, you have to tell me the name, IUPAC name of this compound. Very easy. Come on, I will be waiting. Come on, I'm waiting for your answer. Come on. This is very, very, very easy. Let me know in the chats quickly what will be the answer. Which option is the right option? Come on. Everyone. I want answer from each and every one there. Let me know quickly. Let me know quickly. First of all, here two functional groups are present. This is the main functional group, or this is the principal functional group. And this is the principal functional group, so we will number from this one. This is chain terminating. So 2, 3, 4, 5 and 6. So first of all, which type of functional group is this? This is amide. That means our answer should be either 4 or I mean to say 3, because amide functional group is there. It's not this will not act as a functional group. So first and second is incorrect. So either third or fourth. Now, what will be the answer? It is 2-methyl. 2-methyl is this one. So this will be the answer. It is 2-methyl. After that, we will be having 6 carbons in which this CHO will act as a substituent. So it is either aldo because this is of aldehyde, or oxo because it is C double bond O. Now it is 2-methyl, 6-oxo. After that, 6 carbons are there. So hex will be the word root. After that, it will be 3 position which is having double bond. So it is 3N and then 1 amide, or no need to write 1 because it is the chain terminating functional group. So the name of this compound is simply 2-methyl, 6-oxo. After that hex, then 3N amide. After that, you have to match the column once again. N-butane to 2-methyl propane. N-butane and 2-methyl propane are chain isomers. That means from one isomer to another isomer, it is isomerization. That means A is having 3. A is having 3. So it's only first option. A3. After that, this is what we call Friedel-Crafts, this is free radical substitution reaction. That means B is 1. So A3, B1. After that, this is decarboxylation. That means C4. This is Wirtz reaction. That means D2. So it is A3, then it is B1, then it is C4, then it is D, what we call 2. So option number 1 is the right answer. After that, here are few questions. A is this one. It is this phenol. It is this phenol. A is this. B is paracresol. B is paracresol. B is paracresol. C is metanitrophenol. C is metanitrophenol. And D option is paranitrophenol. You have to tell me acidic character order. It's very simple. Here group is -R, or you can say -M. So it's very easy. -R. This is -I group. this is not having any, say group attached to orthometa or para, it's only hydrogens. So let me write down over nitro or this, say neutral or normal. This is plus H group. And remember, whenever you have to find out acidic character of such compounds, first you have to write down minus R, then minus H, then minus I, then neutral, then plus I, then plus H, and then plus R. If you are having, say these groups more than one, then first strong and then weak. Similarly here, first weak, then strong. Now have a look. First we have to write down minus R. Minus R is D. So I will write down D. After that minus H is absent, then minus I is C, then neutral is A, and after that plus I is not there, then plus H is B. So this will be our answer, DCAB. DCAB is the first option. Very, very, very easy. After that, we have a question, phenol on treatment with sodium hydroxide undergoes normal acid-base reaction and results in the formation of sodium phenoxide. So this is A. After that, on treatment with carbon dioxide at a temperature of 300 degrees Celsius and at a pressure of 6 to 7 atmospheric pressure. Now, this is simply coal-base, say a reaction. So what will happen? It will result in the formation of ONA, and carbon dioxide will act here as an electrophile, and it will result in the formation of this one. After that, so this is B. After that, this upon hydrolysis or acidification will result in the formation of simply salicylic acid. So it will result in the formation of salicylic acid, or we can simply say this is C, or this is what we call 2-hydroxybenzoic acid. Now this C upon treatment with acetic anhydride, I mean to say with acetic anhydride, it is like this. This is also what we call AC whole 2. This is AC2 and then O. AC means CH3CO. So AC2 and then AC. This is AC, CH3CO is AC, CH3CO is AC. So it's AC2 and then O, acetic anhydride. Now what will happen? Simple acetylation will take place. So this H will be replaced by acetyl group. So acetyl salicylic acid or 2-acetoxybenzoic acid, commonly known as aspirin, will be obtained. So what will be the answer? Answer will be simply aspirin. Answer will be simply aspirin. Let me mark this with the help of black color. So aspirin will be the answer. After that, my dear lovely students, have a look. We will be having another question. Question is simple. Question is very, very, very simple. Now have a look. CH3, say toluene on treatment with bromine. Toluene. So our question is like this. Toluene on treatment with bromine. Say halogenation, but taking place in presence of light. That means it is side chain halogenation. What will happen? One of the hydrogens of side chain will be replaced by bromine. So benzyl bromide will be obtained. Now after that, this is A. After that, on treatment with KCN, normal nucleophilic substitution reaction will take place. So it will result in the formation of this one. Now after that, hydrolysis takes place, and we know hydrolysis of cyanide will result in the formation of carboxylic acid. So it will result in the formation of this one. So it is 2-phenyl ethanoic acid, that will be the major product. So this will be the product. This CN gets converted to COH, and then this benzyl group remain as such. So this is 2-phenyl ethanoic acid. After that, we will be having another question. Question is very, very, very simple. Question is like this. First one is like this. First one is this one. This is aniline, this is A, or this is first one. This is first one. After that, second one is like this, para-nitroaniline. It's para-nitroaniline. Third one is meta-nitroaniline. It is meta-nitroaniline. And fourth one is this one. It is benzyl amine. When these nitrogenous bases are there, or when bases are having similar type of elements, suppose N, Then you have to check their lone pair. This lone pair takes part in resonance. That means this is delocalized lone pair. This will take part in resonance. So this is delocalized lone pair. This will take part in resonance. So this is delocalized lone pair. But this will not take part in resonance. This is localized lone pair. And remember, localized lone pair is, I mean to say, that base is stronger base as compared to delocalized. What we have to tell here, pi bond will be broken. Give H to this. Give H to this. Similarly, this will be broken. Give H to this. Give H to this. So it is PH2, PHCH2, then CH2, then CH, then PH, and then this is CH2OH. So its option is PHCH2, CH2, CH, PHCH2OH. That means option number 2 is the right answer. Let me know quickly. Let me know quickly. Am I clear till now? Let me know quickly. Let me know quickly in the chats. Am I clear till now? Let me know quickly in the chats. Am I clear till now? Am I clear till now? Let me know quickly. Okay, it's clear. After that, we will be having a last question. It is this one. You have to match scurvy. Scurvy. You know, scurvy deficiency disease is because of ascorbic acid. I mean, say vitamin C. That means A is 3. A is 3. After that, convulsion. Convulsion is because of what we call pyridoxine. That means it is, I mean to say, B is 1. So A3, B1. After that, cheilosis or chylosis, it is because of riboflavin. That means vitamin B2. So A is what we call 3, B is 1, C is, I mean say 4, and then D is having 2, vitamin A. So it's option number 3 which is the right answer. So option 3 is the right answer. Option 3 is the right answer. So this is all about today. I hope you liked this session, and I will be waiting for your comments after I end this stream, but do let me know in the comments that what was your score? Yeah, what is your score out of, I mean, say these 20 questions? What is your score out of 20 questions? Let me know in the comment section after I end this session. So take care, bye-bye, and love you all.